So yesterday we talked about Pythagorean theorem, and let me get an example up here. Pythagorean theorem is that it's a theorem named after that famous philosopher Pythagoras, right? And where are you at, B? There we are. So let's go ahead and do one more example. Let's see, 8, no, 12, 7, 9, 12. Yeah, we'll do that one. So I'm going to have you copy this down here. How many examples did we do yesterday for our notes? Was it 2 or 3? So this is example 4. So I'm really making this a continuation of yesterday's notes, example 4. So go ahead and draw that. I got 2 right triangles smashed up against each other, forming what we call a parallelogram. Notice that. They're 2 right triangles that are smashed together. I'll give you about 30 seconds to draw that puppy. Again, you don't have to draw a Picasso drawing. Just here you go. I see a right triangle. I'm going to highlight in Dodger blue since they're going to win the World Series. Look at that. Look at that right triangle right there. Let's solve for x. Okay, so I'm trying to think of yesterday's lesson. Pythagorean theorem says, yeah, a square plus b square equals c square. In other words, this is always a leg to the second. The b is always a leg to the second, and the c is always a hypotenuse, right? That's yesterday's assignment. We kind of dove into the Pythagorean theorem yesterday. That was the first lesson of the summer. Medina, no computers right now? I just need you to focus right here, okay? No diddling with anything. Focus like a laser beam. All right, rocking and rolling. What are my 2 legs? Ruiz. 15. What in 15? X in 15? I like 6, huh? Right. The 2 legs are the 2 sides that make up the right angle right there. That's my 2 legs. X squared plus 6 squared is, the hypotenuse is always the longest side. That's number 1. And it's always opposite the 90-degree angle. It's a side that's never touching the 90-degree angle. So that's going to be 15 squared. Rocking and rolling. Nice. Nice. So we ended class with this yesterday, right? That P stamp assignment. Some of you still owe that to me, by the way, for that P stamp. Some of you finished it. Watch this. X squared plus 6 to the second power is not 6 times 2. A lot of you are biting the bait and being tempted to just go, oh, that's 6 times 2, that's 12. No. That means 6 times itself, which becomes 36. And then 15 times itself becomes, I have no clue. Thank you. Remember, I was in a math major. You guys remember what my major was? Philosophy. That's the best major. Trust me. You take an intro to philosophy course, you'll know why it's the best major when you get to college. It's the gravy of all learning. It's the gravy of all academics. But I digress. So x squared plus 36 equals 225. Okay, we want to get x by itself. We want to get it isolated. And I got to do something to both sides. Help.
Subtract 36 by itself and the same side together.
From both sides, yes. I want to do the opposite of adding, so I'm going to subtract 36 from both sides. Love it. Love it. Because our goal is to isolate x. That means get it by itself. I got x squared equaling, watch this now. I have no clue. I'm bad with mental math. I suck at mental math. I'm not good with numbers. I was a philosophy major. So 225 minus 36. Thanks, guys. Appreciate it. Thank you. Good looking out. Nice. So let's get x alone. Square root both sides, because that gets rid of the second power. In other words, it undoes the second power. So I have x approximately, not equals, approximately the square root of 189, because I think 189 is an irrational number. Let me check. I could be wrong, though. Nice. Square root 189, 13.7 to the nearest tenth. I love it. So it's about 13.7, approximately. So on your notes, go ahead and put approximate. That's an approximate answer. But what if I said, you know what, I don't want an approximate answer. I don't want some ballpark estimate of what x is. I want the exact answer of what x is. Hit it, Farias. Did I run it wrong?
No, I'm answering your question.
Okay. Well, we did. It's approximately 13.7. We rounded it. No, I like how you're thinking. Thank you, though. But I don't. My question is this, Farias. What if I said, you know what, I don't want you rounding nothing. I want to know exactly what x is. Don't give me no ballpark, rounded, approximate answer. I want to know what is exactly x. Oh, Sodia's going, why? Tell me, what's on your mind? In one sense, you're kind of right in doing this. What do you mean, though? It keeps going on forever. In other words, check this out. It goes on forever. We talked about that yesterday. But even though you're right, there's still a way to express my final answer in an exact way. And that's what I want to talk about right now. In other words, watch. X equals the square root of 189. That's the exact answer. So go ahead and write exact. Look at, I could write equals. X is square root of 189. Once I type that in the calculator, though, I'm already approximating. But the square root of 189, since it turns into an infinite decimal, we call this an irrational number. It's irrational. Which is why we have to approximate. So go to write the word irrational and put an arrow there. So even though it's irrational and I have to approximate, there's still a way, though, to express it at an exact answer, but there's a way to simplify the square root of 189. That's what I'm going to talk about. We're going to simplify square root of 189, but in a mathematical way. Watch. All right. Back over here. Here we go. So that's the exact answer, square root of 189. But if we're going to leave it as an exact answer, we actually have to simplify it. In other words, what I mean by simplify is kind of like when you're like remember in elementary school? If you have like 4/8, you never leave that fraction unsimplified. 4/8 reduces to what? 1/2, right? In other words, this is the simplified version of 4/8. It's the same thing. They mean the same thing. But this is a simplified, right, version of that. In the same kind of way, we're going to simplify the square root of 189. I don't want an approximate answer. I want the exact answer, but simplified. And here's how we do it. You got to focus now. It's only second day of summer school, and you can get lost quick if you start wool gathering in your mind. You got to focus now. Watch. Off to the side on your notes, we're going to make a list of what we call perfect squares. Going to write perfect squares. What I mean is square roots, perfect squares. And watch this. Stay with me. Going to write perfect squares off to the side, maybe on the margin. It's going to go top to bottom. What's the square root of 4?
2.
Thank you. Then what's the next perfect square up? After square root of 4, what's the next perfect square that's higher than 4?
6.
No, there's no perfect square for 6. Good job, though. Good try. Square root of 8, there's no perfect square for 8.
10.
Square root of 10, no. There's no such thing times itself that becomes 10. 9. Square root of 9 is 3, huh? You with me? Perfect squares. What's the next one after 9? 16. Now we're talking. And we got 25. Now we're talking. Right, 81 is 9 times 9, so we can keep going. So let's just go up to 9. Here we go. Do it with me. So 25, the square root of 25 is 5. Square root of 36 is 6. So 7 times 7 is 49. Look at, you could go the other way, just multiply 7 times itself. We got 8, we got 64. 9, we got square root of 81. We'll go up to 10. How about that? Careful. What's 10 times 10? You're awesome. So, perfect squares are these numbers. Perfect squares. So just list them with me. You'll see where I'm going right now. You're probably asking, why is he listing perfect squares? What's the point? You'll see right now. It has to do with simplifying the square root of 189. See that square root of 189? We're going to simplify right now, but we need to write down our list of perfect squares. So do that for me. All right. Now, why do we do that? What's the point of listing our perfect squares? Here's the point. The square root of 189. Can I rewrite it? Watch this now. Can I rewrite it, the square root of 189, as the multiplication of one of these as a factor of it? Watch, in other words, watch. The square root of 189, what number out of these listed fits into 189 as a factor? Let me start with the first one, 4. Does 9 fit into 189? Yeah. I think you're right, but let's start with 4 first. Watch. So look at 189 divided by 4. Let's see if 4 goes into evenly. Watch. No, it doesn't. Okay, let's try the next one, 9. 189 divided by 9. Boom. Goes in perfectly. So watch what I'm going to do. I'm going to rewrite 189 as 9 times 21. The square root of 189 is the same as the square root of 9 times 21 because 9 times 21 is just 189. Write that down first before I go further. You'll see where I'm going. Just write it down. Now watch this. What is the square root of 9, though? What is the square root of 9? 3. Right, look, it's 3. So look how I'm going to rewrite this now. 3 times the square root of 21. Because square root of 9 becomes 3. So this is x now. This is my final simplified version of x. Let me get that. You guys are doing awesome. Remember, I wanted the exact answer. This is it. 3 times the square root of 21. In other words, instead of saying square root of 21, another word that means the same is radical. So 3 radical 21, or 3 rad 21 for short. So whenever you hear the word radical, it means the same as square root. From now on, just know that. So this is the same, look at, so 3 rad 21 is the same as square root of 189. But this is just a simplified, look at, go and write this down, simplified version of rad 189. If you're doubting me, let me prove it to you. Some of you are doubting me. I could see it. I'm going to press, look at on a calculator, I'll hit square root of 189, watch. For you doubters out there, watch. Let me show you that's the same thing. It's the same value, watch. Square root of 189, watch this. Fadias, check it out. Square root 189, 3.7, blah, blah, blah. We already knew that actually from about 10 minutes ago. But look at now, I'm going to type in 3 square root of 21. 3 times square root of 21, Baruman. Watch. It's the same thing, watch. 3 times the square root, 21. Same thing. So in other words, this is a simplified version of that. So if we're working on a problem and I ask for the exact answer, not the approximate answer. Yesterday we'd been doing approximate. That's easy. Just type in the calculator and round the nearest tenth. If I want the exact answer, I'm asking for this. Let's try one more. That was example 4. Let's try example 5. Simplify the square root of 20. So we're not going to do a Pythagorean theorem problem. I'm just going to just simplify that. Go to write simplify square root of 20. Square root of 20. I have the floor now. Thank you, ladies. Here we go. Square root of 20, that's irrational. In other words, if I type that in a calculator, it's going to be an infinite decimal. Watch. Square root of 20. Yep, it's irrational. So what I want to do now is simplify it. How would I rewrite 20? But with one of these factors, 4, 9, 16, 25, which one of these fits as a factor of 20? 16 doesn't fit into 20. Good try, though. 5 is not listed here. 25, well, 25 doesn't fit into 20. So look at these numbers. Which one of these is a factor of 20? 4 is, look at 4 times what is 20? Look at. But what is the square root of 4? It's 2. So it's 2 rad 5 is my final simplified version. Questions? So this is the same as that, just simplified. That's all we're doing right now. Simplifying square roots. Because where I'm taking you is trigonometry, and when I take you to trigonometry, you need to know how to simplify square roots. It's going to get crazy in here when we get into trigonometry. It's going to be fun, though. Example 6. Dodger blue now. Square root of 200. Phone away. Thank you, Castillo. I have the floor. Welcome, welcome. Have a seat anywhere, and I'll be right with you. Just get some paper out. I have some paper if you need it. All right. 200, is that irrational or is that rational, Secundino and Mendoza? Is that rational or irrational? Who said that irrational? I couldn't. Who said it? Why? Give me an argument. You're right. You're right, though. Give me an argument. Go ahead. Help him out. He's on. Right. It's an infinitesimal. In other words, if I punch that puppy in, watch. Square root of 200. Square root of 200. Yikes. Square root of 200. Infinitesimal. So we got to simplify that puppy. So what numbers from here will fit into 200? Nice. Nice. Notice 100's right here. That's a perfect square. That'll fit into 200. Here we go. So let me rewrite 200 as 100 times 2. Nice. So the square root of 100 becomes 10. It's a perfect square. So I got 10 times the square root of 2. Done. That's the simplified version. So what's key right now for you guys to get in your skull is that these perfect square numbers are your friend. You want to pick from these numbers to figure out if they're factors of whatever you're dealing with. Not just any numbers. They got to be these numbers right here. That's the key. Which one of these numbers fits into it? I'll do one more. And then we'll get into our next session. Example 7. Let's do the square root of 40. Let's simplify that puppy. You sure? All right. Yeah. Rational or irrational? Definitely irrational. There's no such number times itself that becomes 40. So let's break that puppy down. Castillo, you using a calculator? Cool. So I'm thinking in perfect squares now. Here we go. Square root of 40. 4 fits into 40 for sure. 4 times 10 is 40. Again, notice I got the 4 from this list. I'm looking at this list of perfect squares to see if they're factors of 40. Not just any numbers, these numbers. These are the ones I care about. So 4 times 10 is 40. That becomes, square root of 4 becomes 2. And I got rad 10, rocking and rolling, rolling and rocking. Give me one light, Farias. Ruiz, just right here, just for this activity. Behold in my hand is an easel board. Behold in my hand is a marker. You and your partner are going to try one each. One person coaches while the other person does this on the board. Secundino, right here, man. I'm talking like this. Jeez Louise. And when you're done, you hold it up. I'm going to be in the back of my desk sipping coffee and relaxing. You're going to hold it up to me, and I give you a big fat thumbs up or a big fat thumbs down. If it's a thumbs down, you erase it and go back to the drawing board, you and your partner. So one partner does number 1 while the other one's coaching, You get it right, you switch. So you and your partner are going to do 2 problems each because there's 4, obviously. I'm going to give you easel board, marker, eraser. Just use your sweater, but if you don't want to stain it, I'm going to pass out some of these, okay? Get busy. Barker, just come right here with Shields just for this real quick. Sorry, Shields. Boom, hit it. You and your partner decide who's going to do number 1. Galvez, right? Or Galvan? Galvez and Osorio, hit it. I want you talking. You guys are human beings. You can talk to each other. Your last name again? Solis Rodriguez, hit it. You decide who's going to go first. Colbian Baruman. Last name again? Lopez and Solorio. Castillo, rock and rolling. She's still catching up. You're going to do solo. Just pick any 2, and I'll be your partner. Here's yours, and here's yours. Let me give you a marker, too. And here's your marker. Medina, you're with him. Hit it. Yeah, I'm going to give you right now. Give me a second. That'll help, wouldn't it? Good catch. Use those. If you need an eraser, go get the paper towels in the front. I'll pass it out right now. Hold up. Hold up your answer 1 at a time. Don't do all 4. 1 at a time. I'll come around and pass out an eraser. Show me the work. Hold it up. Rocking it. So erase it. Go on number 2 now. So hold up number 1. And then before you switch it, hold it number. So you're doing all 4 at the same time. 1 at a time. 1 at a time. Go for it. One of you 2. Knock that one out. Here's your eraser. Rocking it. Doing number 2 now. You do number what? Which one are you guys doing? Number 2? Do number 1 first. Here's an eraser. 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 Rocking it. Erase it. Go on number 2. You just pick any 2 you want to do, but do 1 at a time. Which one do you want to do first? Go for it. Here's your eraser. You got eraser? You got eraser? Talk to me. I prefer number 1. But let's see what you got for number 2. Keep going, and I'll let you do number 2 first since you're already there. Here's your eraser. Hold that puppy up. Why make the 3 outside so? Asking a question. Why you make it? But you're good though. Go ahead. Go on to the next one. It looks like an exponent is so small. Rocking it. Go on to the next one. Good job, Rodriguez. Wait. One more time? My coffee will come soon. Shields, you're the man. Switch it. And try one again. 4 and 7 don't make up 27, Mendoza. Rocking and rolling, Osorio. Switch it. Good job. Just hold up the board. Rocking it. Switch it now. Good job. Keep going. So square root of 9 becomes 3, so it should be 3 rad 3. 3 normal 3 times the square root of 3. Good. Show them what you did. What's his name again? Medina. What's your name? Last name. Look at Mendoza. Show him. But look at this board real quick. Look how you set it up perfectly, but he made the 9 a 3, rat 3. You see what I'm saying? Go on the next one now. You're making the 5 like an exponent. What? What is that though? You guys are freaking me out.
Yeah.
Put the 5 as normal. Don't make it so small.
What's wrong with being small?
It's not the way you write the math. That actually, here's what's wrong. Look, if you put the 5 like this, that actually means a 5th root. That's a totally different.
For real?
Yeah, it means a 5th root. That's cool. You're learning. So there you go. Next one, go. Rocking it. Go beyond. Rocking it, Barker. Rocking it. Last name. I'll get you. I'm still learning the names. Next one. What do you mean you want to do this? Then I want to give you an R stamp then. Nice. Switch that puppy.